$20 SteadyCam by Patrick Lashinsky. I found this great SteadyCam design by Johnny Lee on his website. He's got some great other projects on there as well, so I copied it wholly and completely. But I made a video, and he didn't. But how does it work? Before we start the project, let's look at some theory. Let's start with the well-known physics formula, F equals ma, force equals mass times acceleration. We can rearrange this to make acceleration the subject, and we get acceleration equals force divided by mass. This means if we apply the same force, a larger mass will have less acceleration. i.e., the heavier something is, the harder it is to move. That's why mobile phone footage looks like this, and professional footage taken by really big video cameras looks like this. Having a heavy camera is all well and good, but I don't want to carry around 20 kilograms of equipment. So we can use geometry to amplify the effects. The angular motion formula tells us that linear displacement is equal to angular displacement times the distance from the center of rotation. Let's look at a seesaw as an example. If you put the axle in the middle, affectionately known as the fulcrum, then both sides are equally distant from the center of rotation. Because the seesaw is rigid, both sides must have the same angular displacement. So if the left side moves 1 meter up, then the right side moves 1 meter down, and vice versa. However, if we move the fulcrum so that the left side is twice as far away from the center of rotation as the right side, then the right side will move half as much as the left side. So, here's our SteadyCam. It has a weight at the bottom and a camera at the top, and a fulcrum somewhere in the middle. In this case, the hand of the person holding the SteadyCam. Now the weight, being heavy by nature, resists movement, and all this lack of movement is amplified at the camera end because it's much closer to the fulcrum than the weight. So in theory, the camera should move very little indeed. Great, now the boring theory's out the way. To build the SteadyCam you'll need 3 pieces of PVC or steel pipe threaded at both ends. These are each 450mm long, 2 matching end caps, and a T-joint. Not 3, but 2 1/4-inch lock nuts, and a 1/4-inch wing nut. I know that's not a wing nut, but I couldn't find one. 2 1/4-inch bolts, 3 1/4-inch flange washers, also known as mudguard washers, and a 1 to 1 1/4 kilo barbell weight. You'll also need a drill, doesn't have to be a drill press, a shifter, a screwdriver, a hammer, and an offcut of pipe. You'll see why later. Firstly, drill a hole into each of the end caps, large enough for the 1/4-inch bolts to fit through. And while we're in the shed, we need to bend one of these flange washers into a shallow bowl shape. You can do this by taking a spare bolt, not the one you'll use because it'll ruin it, and hammering it like this into the bolt, using the PVC pipe as a form. Next, screw the pipes into the T-joint in, well, the only configuration possible. You can't mess this bit up. Fit one of the bolts through an end cap and tighten a lock nut around it. The wing nut, which is not a wing nut, goes on next, and then the bent flange washer on top of that. Fit another bolt into the other end cap, followed by a flange washer, the barbell weight, another flange washer, and then the lock nut. You can now screw both of the end caps into opposite sides of the T, and you're finished. Now let's see the results. This is me running at about jogging pace, even down some stairs. The trick is to always keep your knees bent and run kind of like a dinosaur. There's better instructions on Johnny Lee's page. Thanks for watching. You don't have to rate 5 stars nor subscribe.